We're going to look at another inequality that happens when we're dealing with triangles, and this one actually applies when we have two triangles. So it's called the Hinge Theorem, and we call it the Hinge Theorem because it's basically talking about a situation where we have a hinge. So if you can imagine, I've got two doors here, okay? You can read through this if you want, but it's a little easier to recognize if we actually look at it. Let's imagine this is a door, okay? If I open the door wide, okay, and then I open the same size door, so I've got, you know, these two parts of my hinge, okay? I've got this length, and those are congruent. So this one is the same as this, and this one's the same as this. If I open the left one here wider than I open the right one, then it's going to take a longer line to close the triangle than it would over here. Okay, so we can set up an inequality based on angle measurements. So let's call this angle A and this angle B. And we'll call this, we'll name our triangles here. PQR and DEF. Well, if we've got this situation where we've got congruent segments, okay, so we've got two sets of congruent segments on our two triangles, and we know that angle A, okay, the angle in between our congruent segments, so the angle on this triangle is larger than the angle on our other triangle, so it's larger than angle B. Well, that means that QR is going to be larger than EF. And that's the Hinge theorem. We can go the other way too. We can use the converse of this. And the converse says it would go the opposite way. So if we know the lengths here, so let's say we know that this was 15 inches long, okay, and this one is only 8 inches, but we still got our two sets of congruent sides. Well, since I know that QR is larger than EF, then I know that the angles that are across from those are going to be in the same relationship. So angle A would have to be larger than angle B. And that's the converse. So the Hinge theorem itself, you start with angle measurements, and it gives you a relationship between the opposite sides. And the converse, you start with side lengths, and it gives a relationship between the included angles of the congruent sides. So we'll look at a couple examples here. So here, I've got two triangles. I've got one side that's marked as being congruent, but I can mark another side as being congruent also, because this is a reflexive property. And I can see that this side here, the one that's opposite angle 2, is larger than the side that's opposite angle 1. Since 1 and 2 are included angles, and 2 has the longer side, 2 must be spread out farther than angle 1. So that means that angle 2 is going to be larger than angle 1. Okay, if it turned out that these numbers were the same, so let's say this was 11 also, well, that still gives us that we still get the same kind of relationship. Since we've got these congruent segments here, if I've got congruent lines, that would mean that angle 2 equals angle 1. Okay, let's look at the other direction. So here, again, we're going to have one set of congruent pieces marked. We've got the reflexive property again, so we do meet our criteria. We've got two sets of congruent sides in our triangles. And I can see that this angle, this included angle, is larger than this one. So that means the side that's across from that angle, across from the larger angle, which is YX, is going to have to be larger than the side that's across from the smaller angle, ZY. And that's what you're going to use the hinge theorem for.